So, sketching our polynomials. What do we know? We know that the y-intercept will be the constant of the polynomials. We use this one as an example. We've got 1 times minus 1 cubed, so that's minus 1, times 2 squared, which brings us to minus 4. Plot that one in. The x-intercepts are the roots, or the zeros. So we're going to have, for this one, x equals -1, x equals +1, and x equals -2. Okay. We also saw that when x is approaching plus or minus infinity, so when we're out at the extremities, it will act like the leading term. So it'll start and finish in the same spot. This one, our leading term is going to be x times x cubed, so that's x to the 4, times x squared, x to the 6. So we know we're going to start up the top and we'll finish at the top as well. We know the actual roots behave like the power. So if it's an even power root, it'll touch like a parabola. Well, if it's squared, it'll be a parabola. If it's power of 4, it'll be a little bit flatter at the base, steeper at the sides, but it'll have that U shape. Our one, x equals -2, x plus 2 squared, it's going to be like a parabola, but we know we're starting up here, therefore it must be concave up at that point. Okay, the odd power roots will have that horizontal point of inflection, like the cubic. So at x equals 1, we've got a cubic, but we know it finishes up there, so it must come through like that. And there's our curve. Of course, now that we've done some calculus, if we wanted to, we could also identify exactly where those stationary points are, because we could find when the tangent's horizontal. If it can be completely factorised down to a perfect cube, square, quartic, whatever, then we know it's just going to be that basic curve shifted horizontally. This one here then, x minus 1 to the 4, x plus 1 cubed, x plus 2 squared, x minus 2. I'll just put it all in one hit. There we go. Let's have a look at all the features then. The constant, we've got -1 to the power of 4 times 1 cubed times 2 squared times -2, which is, what's that, -8, if I've done that right. So that's why we're cutting down here. We know the x-intercepts are at 1, but it's going to act like a quartic, so that's why it's a bit flatter at the base, steeper at the sides there when it comes through. At x equals -1, we've got a cubic. X plus 2 squared, over here at -2 we've got a parabola. The leading term would be x to the 4, 5, 6, 7, 8, 9, 10. So we're starting up here, finishing up here as well, and we'd get that sort of shape. So that's the idea we're using when we're just doing a rough sketch of a polynomial. And as I say, if they want more detailed information, possibly they would then ask you to identify turning points and things like that. Okay. I said it was going to be a quick one.